Today we will be discussing the effect of prescribed burning on white-tailed deer food and cover availability. Naturally caused fires ignited by lightning have always been a part of nature, burning up the fuel accumulated on the ground floor and allowing wildlife to reap the benefits of new growth spurting up in their wake. Humans have been using fire for more than 200,000 years for a variety of reasons. From the early Homo sapiens cooking their food for the first time to Native Americans using fire to clear landscapes and promote new growth, fire has allowed us to alter the landscape to suit our needs. Native Americans knew that they could use these fires to promote new growth and attract large game animals like deer and elk. Modern-day hunters and land managers use fire to improve habitat and increase the amount of food and cover that is available for many game species such as quail, turkey, and deer. Many state wildlife agencies will burn their public lands. They do this for a variety of reasons to help many different species, but one reason is to increase the amount of food that is available for deer. Here I describe how prescribed burning affects white-tailed deer food availability. Deer have three main food types that they depend on to meet their nutritional needs: browse, mast, and forbs. Forbs are broad-leaved herbaceous plants. Mast refers to fruits such as berries, acorns, and persimmons. Browse is the foliage of woody plants like trees and shrubs. All three of these can be managed with prescribed fire to increase the food available to deer. Examples of forb species favored by deer are beggar's lice, ragweed, and a variety of sunflowers. Browse species include woody vines such as greenbrier and muscadine, as well as tree leaves like dogwood, blackgum, and sumac. Although deer rarely eat grasses, they are important to deer because they provide excellent cover, especially for fawns. The time of year or season in which one burns has a large impact on how prescribed fire affects deer food quality and availability. Dormant season burning generally occurs in late winter, and growing season burns are conducted from April to October. These different burn seasons affect deer forage differently. Dormant season burns are usually cooler burns that do less damage to woody plants and shrubs because the plant's reserves largely are below the ground. Dormant season burns favor a mix of woody and herbaceous plants in the understory. Growing season burns consume the above-ground portion of woody plants when they are more vulnerable to fire effects. But these woody plants sprout back quickly after fire. Decades of frequent growing season prescribed fire can be used to reduce woody plant cover and favor herbaceous grasses and forbs. Regardless of burn time, herbaceous and woody plants that sprout back after fire have lower lignin content and are more palatable and nutritious to deer. Nutrients such as nitrogen, phosphorus, and potassium increase in the forage that the deer eat directly after fire, but these changes last for only 1 to 2 months. The fire interval, or frequency of fire, is determined by how often a system burns. The frequency of prescribed burning affects the fuel buildup and vegetation structure and composition. Frequent fire can be used to prevent succession in early succession plant communities. By preventing this succession, frequent fires maintain a forage base near the ground so that it remains available for deer. If fires are suppressed, natural succession allows shrubs and other woody plants to grow taller. These taller plants are not available to deer, and they shade the ground and prevent the growth of other plants. Frequent fire, especially during the growing season, can be used to change the forage base from woody shrubs to more herbaceous plants that are important forage for deer during the summer months when most woody browse has high lignin content and low palatability. Early successional plant communities that are maintained by frequent fire also provide deer with bedding cover and cover for fawns to hide from predators such as coyotes. Ideal early succession composition includes a near 50-50 mix of native grasses and forbs, but keeping a shrub component is also important. These shrubs provide browse for deer in the early spring, produce soft mass eaten by deer in the summer and fall, and provide shade that keeps deer cool during the hotter months. A dense overstory canopy that prevents light from penetrating to the ground often limits deer forage in the southeastern U.S. Many of the high-quality forage species that deer eat are shade intolerant, so without light, the natural forage is not able to grow. Prescribed burns can reduce the mid-story cover in forests, allowing light to penetrate to the ground floor where many different forage species can grow. But overstory removal or reduction through a timber harvest most often is required to allow adequate sunlight to reach the ground. In this instance, a clear cut, or shelter wood harvest, or commercial thinning paired with fire will have best results. Another factor that inhibits the growth of natural deer forage is the dense litter layer that develops with fire suppression. This carpet of leaves and needles prevents forbs and grasses from germinating and growing. By burning off the leaf litter, a land manager can naturally prepare a bare seed bed and promote the germination and growth of grasses and forbs. In summary, removal or reduction of canopy trees allows for the penetration of light that understory plants require. The burning that follows the timber harvest clears the seedbed for germination of forbs and grasses that provide food and cover for deer, respectively. The typical burn regimen recommended to increase the amount of cover and forage available to deer is a low-intensity dormant season burn every 2 to 5 years in conjunction with canopy reduction if appropriate. Fruit production peaks around 2 to 5 years after fire, so the 2 to 5 year return interval allows maximum fruit production for deer. The periodic fires consume the understory stems and promote new growth near the ground, but prescribed burn units ideally should be spread across a property with a diversity of burn return intervals and seasons. Areas with more frequent growing season fires will have more grasses and forbs and provide excellent fawn cover. Conversely, areas with less frequent dormant season burns will have more woody plants and provide browse and produce fruits.